In this tutorial, I'm going to walk you through the basics of conducting a paired samples t-test in JASP. Paired samples t-test is used to compare variables that are measured either within subjects or repeated measures to see if there is a difference between two levels of the repeated measures independent variable. So in this example, let's say that these numbers represent mathematical self-efficacy, so how confident one is about math, either before, or rather both before and after taking a statistics exam. So it's a repeated measures variable. We measure math self-efficacy before and after the exam. And to conduct a paired samples t-test in JASP, you just go to t-test drop down, click on paired samples t-test, and enter in the variable pairs. So I'm going to enter, since this is before after, I'm going to enter after first, and then before is the variable pair I want to compare, and I'll leave it alone as a student's t-test. And I will leave it as a two-tailed test, so a non-directional test, although if you wanted to do a directional test, you could do it as left-tailed or right-tailed depending upon which of the two variables you expected to have a higher mean. I will enter the location parameter, or ask for the location parameter, which is the mean difference, with the average difference between the two measures, and also the confidence interval, and effect size, Cohen's d, the confidence interval for that, and I'll also ask for the descriptive statistics. So in the output window, we see first we have the way that it subtracted to get the mean difference. So it subtracted before from after, which is usually what you want to do when you have a time 1 and time 2 variable, is to subtract time 1 from time 2. So that's why I set it up like that. We have our t observed, which is 2.02, which tells us the mean difference is about 2 times the standard error of the mean difference. 9 degrees of freedom, because we have a very small sample size. The p-value is 0.07. If we're using alpha 0.05 two-tailed, we would fail to reject here because the p-value is ever so slightly too high. It's basically telling us we would have 0.07 or 7% chance of observing the mean difference we've observed, or greater in a sample size of 10 with the standard error that we have. So we fail to reject the null because there's just too much probability of making a type 1 error here. We're making a false positive. And the difference between the means is 0.74. The standard error of that difference, how much difference we would expect by chance, is 0.37. And we see that our confidence interval for the difference between the means ranges from negative 0.09 to 1.57. So that includes 0. So that's another indication that we cannot reject the null hypothesis here, despite the fact that we have a pretty large effect size, Cohen's d. So JASP computes this by taking the mean difference and dividing it by the standard deviation of the difference. The standard deviation of the difference is not given in these output, but if you were doing this by hand, you would have that along the way as you were computing the standard error of the difference. We also have a confidence interval for Cohen's d, which here includes 0, another indication that we aren't certain that there is a difference between before and after levels of mathematical self-efficacy. So all signs indicate that we don't have enough evidence to reject the null here. We fail to reject the null hypothesis. We just don't have enough evidence to do so. And in the descriptives table, we see that the after mean was 5.47, which is slightly higher than the before mean. and the standard deviation was a bit higher after than before, and it also gives you the standard error of the mean for before and after. So that's the basics of how to conduct a paired samples t-test using JASP. I hope you enjoyed that as much as I did.